Today we're going to have a look at the Root2 CNC Router. So it's all 3D printed parts and there's about 200 hours of printing. So let's get into it and have a look. The router I'm using is a Ryobi router and it's 30,000 RPM, as you can see there. So no spindle drive on this, just direct drive. Clamps up through here, slides up and down on the Z-axis via these smoothing rods and this spindle here. Now that's just a standard M8. Anyway, the brackets. Now this is a really cool design, this. The brackets for this are just all done via these really simple bearings. So these are the bearings here, and they were, I think, $20 for 40 of them. So fairly cheap, and I've used a fibre washer underneath mine. What you need to do is you need to adjust your setting by these two nuts here. There's a nut on the bottom and obviously the nuts on the top there. So you clamp them down till you get just the right amount of contact in here, that it's nice and free, but it's not got a lot of slop in it. It actually has a cover. You can see this guy here. You've 3D printed a cover to stop any material going into the bearings there. Up here, and up here, this is where the belt, this GT2 belt, clamps to. So what I'm going to do on this side of it is I'm actually going to put some wing nuts here so that you can detension it, pull the belt tighter, and then just do up the wing nuts. But what it does, it goes through here, and there's a stepper motor that's mounted here. So the belt comes along, goes over these two bearings here, around through the stepper motor, back up over the other two bearings, and locks into place over here. So when you have a look at this side of it, this here, these are the belts. So there's a belt driven system up here. There's your stepper motor underneath. The stepper motor goes in here to move the carriage along. This guy here is your Z-axis, and it'll actually spin up and down. So the stepper motor fits in here, that's the top, and that'll just spin. So if we take that belt off there and we move that, we can see the router coming up and down. So just some M3 bolts holding in here. You can see in here that there's provisions for limit switches, and obviously when it comes along to the end of its travel, it'll want to run up against the limit switch to tell it to stop. So basically I've just put that there so you can see how that is. There's this track here which is held into place in a bracket here, and it's held in here, and all your wiring for your limit switches, your two stepper motors, and your two limit switches on your Z-axis here. All your wiring comes back through here, comes back around through this chain, comes back into here, and then there's another chain that goes along from here back to here to give it the same sort of effect. So if you have a look at how that is there, it does the same thing that way. This standoff here sits here and joins up the other track there. The drive mechanism to drive the spindle carriage backwards and forwards is quite simple but effective. Now what I've done for the demonstration here is I've just put the sprocket on. You can see I've got my fibre washer in there, and again there's provisions for a limit switch in here, and I've just put this together. There's a sprocket there and the belt. The other sprocket will sit up here, and of course another stepper motor. Now if you're wondering why I've got so many of these brackets, the original design just called up for one in the centre, but I think what the machine was doing was actually grabbing and going sideways, so they've put or changed the design to have one stepper per side to keep it nice and rigid. Now I don't know whether I'm going to need to do that. There's a lot more mucking around in the code to do that, so I'm going to try it, seeing I'm only going to be machining or milling carbon fibre in fairly small increments and fairly small parts. I don't know whether I'm going to need that horsepower to keep it from tracking out. So on the side here there's a bracket, and this bracket will actually fit here, and the belt simply slides into that. You pull it tight, slides into that and lifts it up there. So the belt comes around this pulley, comes around this pulley, and they both join here and they drive that along. So basically that's where we're at. If you have a look at the wasteboard, if you have a look at the settings here, you'll notice that the router is sitting at the maximum distance it can sit down. So when I wind this down, that's virtually at full capacity there. So you can see here we're just about bottomed out. So what I'm going to have to do is I'm going to have to use this timber, this size here, which is a 75 by 50, and run slats all the way across the table here to actually be my waste material. So when I machine down in through the carbon fibre, it'll actually machine into this, which will be just about be bottomed out. So again, fairly intricate design here. These here is a pretty simple, and it's got a bearing here with a fibre washer each side. It's got some large penny washers on this side, as they're called, and that bearing is free to move while that's held in place. So that's a pretty straightforward idea, and those washers just act as a guide. So these are the feet that go underneath here. So if we have a look underneath, we've got some nice little feet for it to sit on, and it's got some nice little features where the little screws come up and the nuts fit in there, and they just all tighten up. So I've set this guy up. I've just set it all up loose so I can get it all aligned. But basically that's how it's going to look. Okay, so nice and smooth that way, and this way runs along nice and evenly. If you're wondering about all the different colours, I started out doing it all in green. Actually, I printed that in yellow. That was the first thing I ever printed with my printer, and I just thought I'd do the smallest part to see how it went, and that was the smallest part. So then I changed over to this green, and what I found is the filament kept breaking halfway through some of the prints, and some of these parts take quite a bit. There's 9 hours in this bracket here. These brackets here are 5 hours. These here are 8 hours. Each one of these guys here is about 4 hours to print. So there's, 1, 2, 3, 4, 5, 6 of those to print. As I said, you're looking at around about 200 hours of printing. So I was printing in the green, and the green then decided it kept breaking, and it broke halfway through a print. So then I swapped over to the blue, and I did as much printing as I possibly could with the blue, and then I ran out of blue, and then I started printing with my high-vis yellow, and then I basically ran out of high-vis yellow, so I went to this red. So that answers the question with all the colours. These are a couple that I made, and I did the wrong thing. In the files that you get with it, there's two ones of these, and there's one's called inch and the other one doesn't say anything. So I thought, okay, if one's inch, one's metric and one's imperial. So because we're metric here, I printed the one that wasn't inch. Found out that that is actually a smaller hole than the tube. So I actually printed these and then went and bought the tube and found it didn't fit in. So then I had to reprint these again to take the tube. So unfortunately these guys here, I'd also printed that with the imperial, or the what I thought was the metric, and of course they didn't fit, so I just did some filing on the bottom axis of these to get it to all fit together. It wasn't out by much, it was only a couple of millimeters. The beauty of these, I was able to file these all the way through. But with this guy here being a blank hole, and you can see here I tried a different material on the heated bed, and it actually the print started to lift. So one thing I really like about this design, and it's very quirky what he's done, is he's really put a lot of thought into it. Where the limit switches sit here, section cut out, and it goes down that hole and it comes out that hole in there. So what it means is that if we come around here and have a look, where our limit switch sits here, we'll put a limit switch here with the wiring can go down, can come up and can go inside the tube and come all the way down to this end and come out down the bottom and pick up with this wiring here to go over to the center console. So there's no wiring just running along the bottom of the board here, it's all up and inside. So that's basically how that works. And there's these belts here were, I wouldn't say hard to find, but almost impossible to find. They arrived yesterday, these belts, and one's a 210mm long belt and the other one's a 230mm long belt. So that's the 210 there, and that's the 230 up the top. Unfortunately, you've got to buy them in a set of 5. So I've got, you know, five of those and 5 of those. So not too bad, and I've got a few of these bearings left over. So as I said, to make that part there, and it's pretty good quality, came out of that, nice PLA material. That was about 8-9 hours of printing to do that. You could imagine how heartbroken I was when I was using the green. I got halfway through this and then came out and the extruder was sitting in mid-air, it wasn't going anywhere. So just a waste of time and material. Also printed these in a dark blue because I bought some filament when I first got my printer that it was only about 6 meters long, and I thought I'll just use that up and see how I go. And you can see, you know, not real good quality on the bottom there. So you just need to get your printer set up really good, and which is your height off your bed, and make sure the bed, I always put new masking tape down after each print. Otherwise you get those little imperfections there because of the previous print might have left some material or put a bubble in the masking tape when you've lifted it off. So if you have a look at that one, this is one I did recently. You can see there it's a pretty good finish. That's the bottom finish there. So if we come over here and we have a look now at what's going to control everything, this is our ramps 1.4 board with the stepper driver mods, and here are the limit switches that I was talking about. So it's quite an intricate design. I've got the laptop out here that's set up with what they call Gerbil on there, so that I can actually program these. And you can see here with the, where's my other one? This is it, I've got 2 of them. So these are your stepper drivers, so you've got X, Y and Z, and then up here you've got extruder 1 and extruder 2. So you've got provisions for 5 stepper drivers. So you have to actually clone which actual additional stepper you want. So as I said, if I had this guy here and I had the two drives on it, and that's the y-axis, and I look at this and I go, that's X, Y and Z, I have to clone that over onto here. That's your power supply on here, and there's a Uno Mega board underneath, and it's running the Arduino software, and I'm running the Gerbil on that. So that's it. That's how that unit works. There's also a display for that. So that display, those two ribbon cables there, go onto those two connectors there, and there's also a it's an old-fashioned style, it's the one that's in his camera actually, SD card that you can put in there for programming. And basically, here's all my parts, here's all my nuts and bolts, and there's the little bearings for it. So there's all my printer parts, there's all the nuts and bolts I'm doing, and some wiring diagrams there. When we come over here to the other workbench, when you have a look at this, I've got the NEMA 17 steppers, and I've got my belts, and I bought this. I thought I might use this as the X-axis, as the Z-axis, but I think I'll just try the other one for the time being. There's my little limit switches for it. There's the other chain. There's sprockets for it. So, and there's the little LNU type bearings for the Z-axis. So all in all, it is a pretty extensive project. Would I build it again? Yes. All I'm going to do with mine is basically cut out some carbon fibre parts for my quadcopters, so when I have those rough landings, this guy here will mask that problem. So anyway, that's where we're at with the CNC guy. As you can see, it's quite a free-flowing little machine, and I think the next video I'll be doing is with the thing all connected up and going.